So guys, welcome to our channel once again. In today's video, we'll be answering these 10 questions on the topic chemical equilibria. So guys, this video will be all about dynamic equilibrium. So ensure to stay till the end of this video. Also, if you feel you want to answer any question at any point here in this video, you can always pause this video and try out the question to see if you can get the answer even before we provide the answer thereafter. So let's start with the first question here. It says, a chemical equilibrium can only be achieved in A, open system, B, system B, C, closed system, D, system A. So guys, the answer to this question is a closed system. You can only achieve chemical equilibrium in a closed system. That is a system that cannot exchange substances with the surroundings. So nothing enters and nothing leaves the system. So let's consider the next question. Question number 2, it says, at equilibrium, the rate of the forward reaction is A, 0, B, lesser than the rate of the reverse reaction, C, equal to the rate of the reverse reaction, D, greater than the rate of the reverse reaction. So guys, the answer to this question is option C. At equilibrium, the rates of the forward reaction and that of the reverse reaction becomes equal. That means there is no net difference in the rates of the forwards and reverse reaction. So the forward reaction is equal to the reverse reaction. In this situation, that's when equilibrium is said to be attained in a reaction. So let's consider the next question. Question number 3, it says, in a chemical equilibrium, the rates of the forward and reverse reaction are A, proportional, B, equal, C, inversely proportional, D, 0. So guys, the answer to this question is option B here, and that's equal. The rates of the forward and reverse reactions are equal in a chemical equilibrium. So let's consider the next question, guys. Question number 4 here. It says, Me plus NF yielding Pg plus QH. In this equation, the equilibrium constant is given by A, concentration of G times concentration of H over concentration of E times concentration of F. B, concentration of E times concentration of F over concentration of G times concentration of H. C, concentration of G to the power of P times concentration of H to the power of Q over concentration of E to the power of M times concentration of F to the power of N. And then D, concentration of E to the power of M times concentration of F to the power of N over concentration of G to the power of P times concentration of H to the power of Q. So guys, the answer to this question is option C here. The equilibrium constant of a reaction is given by the ratio of the concentration of the products to the concentration of the reactants, each raised to the power of their stoichiometric coefficients. So having this, we can see that in this illustration, you have concentration of G to the power of P and times the concentration of H to the power of Q over concentration of E to the power of M times concentration of F to the power of N. So you see all the concentrations raised to the power of their stoichiometric coefficients. And that's the answer to this question, guys. So let's consider the next question. That's question number 5. It says, which of the following equations shows that a reaction is in equilibrium? A, delta G is equal to delta H minus C times delta S. B, delta G is equal to 0. C, delta G is greater than 0. And D, delta G is less than 0. So guys, the answer to this question is option B. That's delta G is equal to 0. A reaction in equilibrium has the Gibbs free energy that is equal to 0. So guys, delta G is the Gibbs free energy, and the one that best suits the answer to this question is the one that relates delta G to 0, and that's option B here. Delta G is equal to 0. So let's consider the next question here. Question number 6. It says, dynamic equilibrium describes a situation where A, reaction gives back the reactant, B, the concentration of reactants and products are equal, C, reactions are converted to products, D, both forward and reverse reactions produced at the same rate. So guys, the answer to this question is option D here. Dynamic equilibrium describes a situation where both forward and reverse reactions are produced at the same rate. So let's consider the next question. That's question number 7 here. It says, two boys balanced steadily in a seesaw game is an example of A, mutual equilibrium, B, static equilibrium, C, homogeneous equilibrium, D, dynamic equilibrium. So guys, the answer to this question is option B here, and that's static equilibrium. So the balanced seesaw is an example of static equilibrium since the seesaw is at rest or is at a stationary position. So let's consider the next question, guys. Question number 8. It says, chemical equilibrium is based on A, the equality of the rates of the forward and reverse reaction, B, the equality of the forward and reverse reaction, C, the rates of two opposing reactions, D, the condition of two opposing reactions. So guys, the answer to this question is option A. Chemical equilibrium is based on the equality of the rates of the forward and that of the reverse reaction. So that's it, guys. Let's consider the next question, and that's question number 9 here. It says, chemical equilibrium is based on A, the condition of two opposing reactions, B, the equality of the forward and reverse reactions, C, the equality of the rates of the forward and reverse reaction, D, the rates of two opposing reactions. So guys, we've answered this question before now, and over here the answer here is option C, the equality of the rates of the forward and that of the reverse reactions. So let's consider the next and the last question here. That's question number 10. We have here an equation of a reaction, and then the question here says, consider the reaction A as solid, 2B as gas, reacting to produce 2C as aqueous solution and D as gas. What will be the effect of a decrease in pressure on the reaction? A, the equilibrium will shift. B, the rates of forward reaction will increase. C, the rates of backward reaction will increase. D, the rates of forward and backward reactions are not affected. So guys, the answer to this question is option C. The rates of backward reaction will increase if the pressure is decreased in this reaction. So according to Le Chatellier's principle, if a dynamic equilibrium is disturbed by changing the conditions, the position of equilibrium moves to counteract the change. So guys, in this case, the reaction has more moles of gas in the reactant side. So we have 2 moles of the gaseous substance at the reactant side, whereas the gas at the product side is just 1 mole. So a decrease in pressure, guys, will therefore shift the equilibrium to the side with more moles of gas in order to increase the pressure again. So guys, this will therefore lead to an increase in the rate of the reverse or backward reaction. So guys, that's it for this question, and this is where we'll end the video for today. So if you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. We want to also strongly encourage you to join our YouTube channel community by clicking on the join button. So thank you for watching this video, and see you on the next one.